Now we're going to discuss the difference quotient. The difference quotient is one of the fundamental tools we need for Calculus 1 if you're moving on to calculus. What it does is the difference quotient gives me the slope of the secant line. What's a secant line? A secant line is just a line between 2 points on a curve. So here we have the blue curve, 2 points identified on it. If we draw the black straight line through those points, the slope of that line is the same thing as the difference quotient. How do we get the slope of that line? Well, it's the change in y minus the change in y over the change in x. So here the y, for this point, our y coordinate is f of x plus h. And for this y coordinate, our y coordinate is f of x. Over the x coordinate here is x plus h, minus the x coordinate here is x. And as you can see, these subtract off, and this simplifies to this. Now we're going to discuss it as a rate of change coming up, but first let's practice how to evaluate into that difference quotient. So if I want to figure out what f of x plus h is, I'm everywhere in the formula for f that there's an x, I'm going to replace it with x plus h. So that would look like this x becomes x plus h quantity squared. So if I'm going to square this out, I have to FOIL. So x plus h times x plus h, x times x gives me the x squared, xh and then hx is the 2xh, and then h times h is my h squared. I want to find f of x plus h for this function. So again, everywhere in the expression that I have an x, this x is this x right here, x plus h. This x is this x right here, the x plus h. So distribute the 2x, and we get 2x plus 2h. This is x plus h times x plus h, and we FOIL again to get this. Distribute the negative 5x squared minus 10xh minus 5h squared. Okay, now that we know how to do it, let's go ahead and figure out that difference quotient now that we can plug in. So f of x plus h minus f of x over h is our difference quotient. So for this function, that means everywhere I have an x, I replace it with x plus h. That would look like negative 3 x plus h squared plus 5. That's my f of x plus h. Then minus the f of x is just this function exactly as it is, negative 3x squared plus 5, all over h. Now we FOIL this again, so negative 3 times x squared plus 2xh plus h squared plus 5, and then distribute the minus, plus 3x squared minus 5. And notice that this plus 5 and minus 5 subtract off. Distribute the negative 3. So I get negative 3x squared. That would be a negative, sorry, right over plus minus 3 times 2 is 6xh minus 3h squared plus 3x squared over h. Again, these 3x squareds are gone. And I'm looking at negative 6xh over h minus 3h squared over h. Cancel an h out of each, and we get negative 6x minus 3h. That's our value of the difference quotient there. Let's do it again with this example. So f of x plus h minus f of x all over h is our expression. So everywhere I have an x, I replace it with x plus h. 5 times x plus h squared minus x plus h squared, single, x plus h. That this x plus h is this x squared, and this x plus h is this x. Then minus f of x is the function just as it is, so 5x squared minus x, all over h. We're FOILing here, so that's 5 times x squared plus 2xh plus h squared. Distribute the negative, negative x minus h. Distribute the minus, minus 5x squared plus x, all over h. Distribute the 5. 5x squared plus 10xh plus 5h squared. And now notice this plus x and minus x subtract off, so we have minus h minus 5x squared. And again, this negative 5x squared and the positive are gone. There's an h in everything, so I can write that as 10xh over h plus 5h squared over h minus h over h. And that simplifies to 10x plus 5h minus 1. So there's our value of the difference quotient there. All right, now let's find the average rate of change on each of these intervals. So my average rate of change is the difference in the y-coordinates. The y's would be f of x2 minus f of x1 over the difference in the x-coordinates, x2 minus x1. That's what my average rate of change is. So for this first interval, this is my x1, this is my x2. So over that interval, I would do f of 1 minus f of 0 over 1 minus 0. Plug into this to evaluate the f of 1, we get 1 squared minus 0 squared over 1 minus 0, which is just a 1. Now let's do the same thing over the second interval. That would be f of 0 minus f of negative 2 over 0 minus negative 2, or 0 squared, plugging in here, minus negative 2 squared, plugging in here, over, that would be a positive 2. So that's a negative up front, positive 4. So minus 4 over 2 is a negative 2. Okay, so our average rate of change over this interval is a 1. Our average rate of change over this interval is a negative 2. Now if we do it with the difference quotient, over the first interval, we would go f of x plus h. Well, I'm going over the interval from 0 to 1. This is my x, and the h is the ending point minus the starting point, so 1. So I would go f of x plus h would be 0 plus 1 minus f of 0 over h is 1, and we get the exact same answer, 1. Over our second interval, we would do the same thing. That was the interval from negative 2 to 0. So f of x plus h, well, notice that my x is the negative 2, and then the h is the distance to 0, which is a positive 2. So negative 2 plus positive 2 minus f of negative 2 over the h value is 2. We get the exact same thing, a negative 2 for that. Notice that they're the same. The average rate of change equals the difference quotient, which equals that slope of the secant line. So all three things, average rate of change, difference quotient, slope of the secant line, they're all telling you the same thing about the function.